as much as 1, 2, or 3 days, whatever it turns out to be?
Well, let me start off with a broad view of this. Each of the launch opportunities that we have identified for the missions is a green opportunity. In other words, these are the ones that when we were asked to categorize them, they were all green. Now, there are, of course, additional details that happen as you move day by day, and let me ask both Rich and Tony to just give you a couple of simple examples of how things will change on a day-by-day slip. Rich?
Yeah. LRO is fortunate in that the moon is nearby. It's our closest neighbor in the solar system. And unlike other planetary missions that have small windows every few years, LRO has favorable windows of 4-day intervals approximately every 2 weeks. The windows are there because we want to arrive at the moon with good lighting conditions at the next winter and summer seasons on the moon. So we'll be in the noon-midnight orbit then and make precise measurements of the temperature variations in the polar regions. All of the days this week, as Mike indicated, were favorable these 4 days. And so we're very happy to have these launch opportunities now.
Likewise with LCROSS, each of the days identified were green days, both from a spacecraft performance and measurement standpoint. On the observatories, as you know, they've clustered in Hawaii and the West Coast, and that is deliberate to be robust against possible launch delays. And so we will get all of our primary observations in Hawaii, which is what's critical to our ground-based campaign. And of course, it doesn't affect at all the impact. This particular opportunity is fantastic. We get very steep impact for every single launch date. So none of our performance in flight or at impact will be affected.
Any other questions?
So a quick follow-up on that. Is there a date at which the continental states will be lost from a viewing opportunity?
Yes, that would be a launch on the 20th. We would lose most of the continental United States, but we'd still have Hawaii, which has always been on prime.
Any other questions?
So I'll just keep going. Mr. Vondra, you mentioned that only a small portion of the moon would be mapped in the first year. I wasn't clear if that was just in a small portion at high resolution or if it would take longer.
Over the course of a year, we will measure the global moon with high resolution, at least at a 100-meter scale. We have cameras that measure smaller regions with a pixel size or a resolution of 50 centimeters, 1.5 feet, so that we will see small objects and measure the terrain with very high precision. However, because of the large data rate that's coming through, we're getting several hundred gigabytes of data each day. Because of that very high data rate required to map with that precision, we'll only be able to map a few % of the lunar surface with the 50-centimeter resolution. And that's why we've gone through this process of selecting the 50 highest priority sites for exploration, and then we are assembling a list that will be probably several thousand sites that we will measure that are of value not only to future explorers but also the broad science community.
Yeah, and if I can just step back for a second and look a little bit more broadly at the mission. The mission was designed from the very beginning, first of all, for the vast majority of the time, to be looking directly at the moon all the time. And most of the instruments are designed that while the spacecraft is looking at the moon, they're taking measurements continuously during the whole mission. For example, the laser altimeter will be working continuously and be putting down about 4 billion shots, 4 billion spots on the moon over the course of that year.
Any other questions, sir?
You talked about how the data is going to be available on the PDS. What about for the general public? I know there's once Google Moon was mentioned. For the non-scientist, how will they be able to interact with this information?
Should I answer that?
Sure.
Yeah, all of the data will go into the planetary data system in a very timely way. This is the mechanism by which the science community accesses data. And also the public can use that, like for educators. But we have a plan in order to, first of all, have our results given to the public and made available to everyone in a very timely way. We expect some significant discoveries from LRO, and so we will work as a team to make sure those results are accurate and then to release them to the public. We also have education and public outreach programs for the entire mission and the individual instruments. And regarding the camera, the LROC experiment team is working to have a public website where actually individuals can propose a target of their own that they would like to get images from. We think this would be very appealing to educators and students. There's a similar program that's operated like that for Mars. And we look forward to that as a way to engage the public and inspire the next generation.
And on LCROSS, we have a shorter mission, of course, but and it's a real-time mission. Everything on LCROSS is from flying the spacecraft to the impact is now. There's no repeat. So in that vein, what we are actually doing to engage the public is streaming our camera video live to the web. So the entire community worldwide can see what we see in the Science Operations Center at the same moment, more or less, as when we see it. Also, if we're fortunate enough to have viewing, if you're in an area where you do have viewing, a modest telescope, 10 or 12 inches, you should be able to observe the flash and ejecta cloud, depending on, of course, on weather. So the LCROSS is trying to engage the community in a variety of ways, also through getting amateur astronomers who have helped the professional astronomers understand the illumination of the moon and how to find a crater on the moon. If you haven't looked at the moon before and you're asked, go find a crater with your 10-meter telescope, it's a hard thing to do. So we've actually, for the last year, worked with amateur astronomers who are very good at this. They've actually helped the professionals develop a whole means of using guide craters instead of guide stars to point these very large telescopes. And so we've already actually engaged a large portion of the public for help in our mission. And then we'll be hopefully contributing to the real-time sense of the mission in a couple different ways as the LCROSS mission unfolds.
Okay, now we'll take a call-in that we have online. I think it's Tariq Malik.
Thank you. This is Tariq Malik from Space.com and Spaces. I think I have one and a follow-up. And my first one, actually, maybe for all three of you up there. I know this mission was delayed a while, and I'm just kind of curious how it feels personally to you and maybe to your team to kind of be at a point now where, despite those delays since October of last year, you're ready to fly and you're ready to start your mission.
Well, one of the things that we all know about the developing missions for flight, and that is that it's a tough job. And we know that we can't always be able to launch exactly when we want to, and most of the time, in this case, most of the time, it wasn't related to issues related with either the two missions that we're talking about here. But I tell you, the three of us are sitting up here right now really excited because this is where, after all of this hard work, we really start to capture what we've all been involved with and started out to do, and that's to get the information that we're looking for. It's going to be an exciting time for the